Hello, today we are covering 6.8, Analyzing Graphs of Polynomial Functions. And what we're going to talk about is relating the different pieces, so zeros, factors, solutions, and intercepts, which we kind of did yesterday when we talked about how to write equations in an intercept form and in standard form. Remember, intercept form and factored form are the same way. So we're going to start with a zero. If we have a zero, that means k is a zero of the polynomial function. So we've got x is equal to k. That is a zero on our graph. If it's a factor, we've got x minus k. So if I have a factor, that's when it's set equal to 0. So I'm going to move that k over by subtracting k from each side, and we've got x minus k is equal to 0. If it's a solution, k is a solution of the polynomial function when f of x is equal to 0. That means when y is equal to 0. And it's an x-intercept. If k is a real number, then k is an intercept of the graph, the x-intercept. Now the only difference between a solution and the x-intercept is solutions can be real and imaginary. An x-intercept is only when that solution is a real number, and you would see that on your graph. Alright, so if you don't have your calculator out yet, go ahead and get it out. Alright, we want to start by sketching our graph. So we go to our y equals, we type in our equation 2x raised to the third power minus 5x plus 4. We always want to make sure that we're starting off in a standard window. So we start by doing zoom 6 just in case we had changed our scales for a different equation. And we sketch our graph. We see that we have our cubic style function there. What important points can you find? So when you look at your graph, you think about everything that we've done this semester. Think about what are the different points that you could find on this graph that would be important to the shape. Hopefully one of them that you said would be the x-intercept. If I wanted to find the x-intercept, that's when y is equal to 0. That's our horizontal line there. So we go to our y equals, and y2 we enter in 0. And now we want to find the intersection point between our graph and that horizontal line. So we go to second trace. We want the intersection point number 5. First curve, you can see on the left-hand side, it's the parabola. Enter. The y equals 0. Enter. And you can either scroll towards the point, or you can just hit enter again. And we are given that our y-intercept is at negative 1.89, comma 0. And again, that's the, sorry, not the y-intercept, the x-intercept. That's where our graph is crossing the x-axis. Now another point that's important that we can find is our y-intercept. If we are looking at our y-intercept, the y-axis is the equation x equals 0, a vertical line at 0. To find our y-intercept, we go to second trace. We want the value for when x is equal to 0. And we find that our y-intercept is at 0, 4. Now if I just had those 2 points on my graph, I would not be able to sketch my graph without looking at the calculator. So there's a couple other important points that we want to look at. And those important points are our turning points. Our turning points is going to help us describe the graph shape. And so if I'm following my graph, it's going up, it's going up. This would be a turning point because that's when my graph changes direction from increasing to decreasing. And then it decreases, decreases, decreases until we get here, and then again it changes direction from decreasing to increasing. So the turning points are where your graphs are changing directions. And you can have local mins and local maxes. You can also have absolute mins and absolute maxes, which we'll talk about later. But our local min is the point lower than all nearby points. But just remember, this is not necessarily the absolute min. So when we look at our graph, this would be our local min. That's the short or the lowest value, but it's not the absolute min because my graph is continuing down forever and ever. Our local max is the point that is higher than all nearby points. And the same thing is true here. It's not necessarily the absolute max. So when we look back at our graph, this would be our local max. It's not the absolute max because our graph is going to continue up forever. And when you are looking at your graph, every polynomial has at most, and again, at most doesn't mean it's going to have exactly that number, is n minus 1 turning points. So when we look at the equation that we just talked about, that was a third degree polynomial. Well, n would be 3 minus 1 would be 2, which means that the graph that we just had would have at most 2 turning points, which it does. It has one local min and one local max. Alright, so we're going to go ahead and find these local mins and maxes. So for each of these problems, we want to sketch the graph, describe the end behavior. This is a review, so this is not new, the end behavior. Find the x-intercepts, find the local min and the local max. So we look at our first one, we've got x to the 4th. We're going to go ahead and go to our calculator, type that in. Make sure that you always double check after you typed your equation in that you've plugged all the correct numbers in. If you've done minuses instead of negative signs, the biggest mistake is always forgetting a number or typing a number in incorrectly. We hit graph, and I can't see the bottom of my graph, so what I have to do is I have to change my window. I want to go farther down, so I change my window. I'm changing the y because the y moves up and down. The min is going to make us go down, so I'm going to change that to a negative 30. That's just going to be kind of a guess and check. Kind of keep on changing it until you can see the whole thing. Okay, so now we're going to sketch that graph. And it is a sketch, but you want to make sure that it's a relatively accurate sketch. And that's not good. Some of these graphs are not the easiest things in the world to graph, so just do your best at it. The first thing that we want to do after sketching it, part B, was to describe the end behavior. So again, the end behavior, how is y affected as x approaches positive infinity? So as my x gets larger, as it's continuing to get larger forever and ever, we see that our y is going to forever continue up, so y is going to approach a positive infinity. What happens to y as x approaches a negative infinity? So as our x gets smaller and smaller, we see that it's still opening up, so that's going to approach a positive infinity. Part C is find the x-intercepts. Now we double check, we make sure that we still have that 0 and y2. We want to find our intersection points. First curve, enter, second curve, enter, third, enter. And we're going to go ahead and make sure that we label that on our graph. So our first x-intercept is at 2.55 comma 0. And we're going to find our second one. Enter, enter. Make sure that you scroll over, or you're just going to get the exact same intersection point again. And we find that our second intersection point, oh, it did it to me. So number 5, first curve, second curve. I guess we got to scroll closer. And we get that that second intersection point over there on the left is at a negative 2.89, comma 0. Now don't forget, I can also ask you for the y-intercept. If we want the y-intercept, we plug in that value. And our last is local min and local max. Those are all of our turning points. Since our degree is 4, that means we can have at most 3 turning points. So we have our graph going down, 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 down. Once it reaches this point, it goes up, up, up. Here it changes direction again, all the way down to here. So we have 3 different turning points that we need to find. Let's go ahead and start with our local mins. So we've got, this is a local min. This is a local min. So we go to our calculators, we go to second trace. We used to do the min and max for our vertex. We're going to use those same 2 things here. So we're going to find this min and value first. Is that left of the min? Yes. Then once you go right bound, just make sure that you don't go so far that you've crossed into your other turning point. Enter. Go back. And we find that our first local min is at a negative 2.24, comma negative 6.53. Alright, let's go ahead and find our second local min, second trace. We want our min value again. We've got to scroll over. We are left of the min, enter. Scroll right, so it's just like we're finding 2 different vertexes. Go back towards the middle, and our second local min is 1.59, comma negative 25.82. Now we've got one last thing to do, and that's to find our local max. So we go to second trace again. This time instead of 3, we want 4, our maximum. And again, it wants to be left bound. If that's the highest point, we want to go left of the highest point, so we've got to keep scrolling left until we've crossed over the turning point. Make sure that you don't go too far. Enter. Scroll to the right. Cross so that you're right of the vertex. And back towards the middle. And then we have our local max is a negative 0.84, comma negative 0.84. Okay, so in this case we had 2 local mins and 1 local max. Make sure that you label these points on your graph and then fill them in when necessary. So a lot of times you're going to have a blank at the bottom. Make sure that you do it both on the graph and on the sheet of paper as well to get full credit. So again, the local min, the local max are just like different vertex points on your graph. We've got 2 of our graphs opening up, so that's the lowest point, giving us the min, that's the highest point, giving us the high. But notice that this right here is not only a local max, it's going to also be the absolute max, because that's the lowest point on the entire graph. This is a local min, because it's not the lowest point, but it's one of the lowest points. Local max, those 2 points are going to be higher. Okay, I know a lot of calculator work, which can be difficult. What I want you to try doing is number 2 on your own. So go ahead and press pause. Okay, make sure that when you graph it, you turn your zoom back to zoom 6 so you have a standard window. If your graph does not look like mine, go ahead and double check your equation. Make sure that you typed it in correctly. So the first thing that we do after we sketch is to find our end behavior. So as my x's get larger, I see that my graph is going to go down, so my y is going to approach negative infinity. As my x's get smaller, my graph is going to continue up, approaching positive infinity. If I want my x-intercept, remember this is when your y is equal to 0, so this should be your y2 in your graph. Then you've got 3 different intercepts that you need to find. The local min, remember they're the turning points. So I've got a local min here and a local max there. You're going to use the min and max value the same way you would find the min and max on a vertex of a parabola. You've just got multiple different pieces to find. And now you are done for today's video.